Hello. So today I will just talk about this tutorials of how you set up the cylinder drag coefficients because some of you may have some questions about this tutorial. So first of all, if you follow the instructions very carefully for this problem statement, you'll see how this works, especially how can we calculate the drag coefficient for a cylindrical shape when it's passing through water. The fluid here is liquid, which is water. And also, you solve the problem for three different values of Reynolds. One is laminar, the other one is uh, still laminar, and the third one is turbulent. So you will learn how to use the clone and other things. Very interesting here. Especially this will help you when you try to do some optimization and how can you show results for different readings. So you have the parts and you need to open the parts. Because of the time, so I have done this before, and then I will show you some of the things, maybe all the hints, if you want to go and fix them if you have missed. So first of all, I have here the R1, and you can see now I clicked on it before anything. I'll go through the process. So remember, because I set up already the project on the wizard, so I would go to input data, general settings, and here I will show you what you choose external, exclude internal space, and that's the analysis type. No time dependency, and then you choose, for example, the fluid is water, as you can see here. Keep it laminar and turbulent, and then initial event, you click on the velocity in the x direction dependency, and when you click there, you'll see that you just type this equation. So this is something really good. Of course, after you changing from constant to formula definition, and then you type this equation in here. Here's the process on the PDF file. It's explained. If you read very carefully, you will really get there. Because I'm using, this will allow you, for example, to copy this equation, and or at least using the PDF professional editor, you can definitely copy this one. Otherwise, you just need to type it and make sure to use the same equation. Why now? The question here is explained. This is for calculating the Reynolds equation or velocity equation by rearranging the Reynolds equation. So that's what you get it in that shape, and the diameter of that cylinder is 0.01, and you get all the values given here, and you can see by after rearranging the equation and the density for water and temperature. Of course, we are not having any issues using just room temperature. And then after that, you click OK, and that setup is finished for the first part. Then the second thing is the computational domain, it is definition. So when you right click on computational domain, you choose 2D simulation. By default, you find these values, but then the tutorials ask you to set up these values 0.25 for x, and for the other x negative 0.15. So if you see what it's trying to do here, kind of you have from that point of x here is about 0.25 meters, and from this negative x, it's on the other direction is minus 0.5 meters, and the positive y is 0.15, and the negative y is minus 1.5. And the explanation is so you can see how the fluid, when it's coming from that direction, how will the velocity profile will look like after that. So when you're happy from this, you need to set up the goals. Here I just tested different things. So first one, for goals, there is the GG global goals. So right click, insert global goals. I also used try to insert surface goals for me just to see how it looks like. And the other one, insert equation goals. So when you click on insert global goals, I'll not do it now, but you just click on force in the x direction, this one. And the other goal, which is the one you set up, is the equation. I will edit this goal here. You type the expression by clicking on GG force X, and that will let you will come straightforward, divided by the equation provided in the tutorials, which is here. The GG force X R1 divided by that equation, which will calculate for you the drag coefficients. You name that here and make sure to change that from any units to no units by clicking on the row, and you go on the top, you find no units. Happy with that, you click OK, and that means we set up for you the drag coefficients. Now the other step is to set up the mesh. So there's the global mesh, right click, edit definition. I'll show you just very simply set up that from 3 to 5, and then keep anything similar or follow exactly the things it's given to you here, which is the same. Now click OK, and then to set up the local mesh, you choose the face, which is for the cylindrical shape, and then you just tick that box for equidistance refinement, and you put the values as stated in it, 1 and 0.04, and then after everything is good, you just click OK. Now, what's something good about this things is like setting solution adaptive mesh requirement. Something is good, and by setting that to a level of initial mesh value of 5, it may not be sufficient to resolve accurately the vortex street behind the cylinder. So it's kind of that will be using this tools, and then from tools, flow simulation, and then you see the calculation control option. And you can see I set it up exactly how it was required by going to refinement, and here ticking all the boxes, approximately maximum cells, the travels, here entering the points too. So you just click on this box, and then you add a row, and then you type 2, and that will give you the information here. And then you make sure to keep the units as travels, and then you go to finishing, and you follow exactly the instructions for its finishing condition. Make sure that refinement is ticked, is on, and the travelers here, you tick it off, and then you click OK. So I am just checking for you. This is exactly what we done for this. Later we'll visit it for on the other Renos to make some changes here, and I'll show you later. Okay. So when you do that, finish, you come to the Renotes one, and then you create a clone, and the clone you name it as R Renotes 1000. So I created that already, and you can see what's a clone is kind of copying the setup we did for Renotes 1 to a new one called Renotes 1000. This is really good when you try to perform some optimization and comparison for different scenarios. So because it's the same geometry size, so we technically we will get that value for it, but we need to follow the instructions here given to us, which very clearly. Now, one of the things for that clone, you need to introduce the time independency and changing the velocity. So go input data general settings, and here you need to tick that box, time dependent. If you don't do that, tick that box, you'll find later some of the information which I will mention later, they will not appear to you, okay? And that will be related to the option which we did early here about calculation control options. When you try to make some changes to it, will not show the physical times, which I will describe later. Anyway, after you click that, you move to set up your velocity in the x direction under initial conditions, dependency, and x. You choose formula definition. You just type the equation to 1e3, and it's the same because the same diameter is just now Reynolds is changed from 1 to 1000. And if happy, everything is okay, you click OK, and then apply, and then you move to the next step. Now, we need to change the drag coefficients. Right click for that, do the definition. I can see a change of the equation following the one is given here, 0.02 times this value I kept the 1, I didn't change it because it doesn't matter, and 0.011 to 10 to the power 3 square, and all of that times 2 times 9.81 times 0.01. So just follow exactly the instructions here to make sure you're in the right direction. Okay. Now you may see here, maybe if you remove that and you keep the brackets, will be exactly the same, or because it's multiplied by 1, so we should give you the same value. But that's very important to keep the brackets and everything. So happy with that. Drag coefficients, no units, keep it like that, and then you move to the next things. Now it's to set up the template, which it's creating templates. You go to tools again, and from tools, flow simulation, and then project, and then you create or what we call it, create templates, which is here. Because I already created that template, so I did it before, like see every time. So my last template was cylindrical drag, so that one it's already created for me. So which I call cylindrical drag 2, because just to show you, I'm repeating this example again. And then you save that template as you can see it later, because this will be based on what we got here. I will cancel it in my case, but for you, just follow the instructions. Now we need to open, so when we finish from that geometry, all good, Control S, I need to open the other one, which is it's C1 meter, which is the biggest one, biggest dimension, and I'll show you how it works here following the instructions. So now when you open that one, that's a new folder, you come to the you open it, but what you do actually, you go back to the original one, and which is related to default and project, and then, or not actually project, what you go, just want to open this one, or it's not opening the same, default. So you just read the instructions here. You come from tools, flow simulation, project, new. So let's go back to it. Project, new project. I'll just open it to not confuse you. And here you choose cylinder drag 2. But because I have done it already, so I will technically cancel it. So what does mean that we'll try to bring everything for you from the last template into what? Into new model, even that model is bigger in dimensions. So that one is 1 meters, the other one was C.01 meters. So that's the template's origin from it. So minimize it. So when you open that one, you will get all the things here. And now we need to go and edit some of the information. So you name that project Reynolds 1E, which means Reynolds 1E5, and then you continue with that cylinder drag, following the options here, and then need to change the boundary conditions, or sorry, the fluid, the computational domain, edit, and you enter the values given here, 25 meters, minus 15 meters, and 15 meters, and minus 15, and follow exactly. You can see all there set up. And then you go and change the input data for the general settings for the initial velocity, the dependency, you select that equation, so just introduce 1E5 and keep the rest exactly like here. And then after that, in the dialog box, you can see what's happened. Here is some explanation to what is going on in the calculations. And now what we need to do as well in that, something is new, is to expand the turbulence parameters and change that value exactly what is showing here to 0.01 meters, which is the value for turbulence length as described here. When you're happy with everything, you click OK and apply and OK, and that's what generates for you. Now, other things, we need to go and update the drag coefficients equation, edit definition. You can see updated to with a new equation, which is 0.2 times that equation to the power square, and 2 times the density times 1. All right, no units, track coefficients, click OK. And then after that, local mesh. For local mesh, you keep it as it is, but what we need to do, oh sorry, the global mesh you keep it, but the local mesh you just need to change the values from that one to be 0.4 meters, and then you click OK. And after that, you go to Tools, Simulation, Flow Simulation, and then the Calculation or Control options, and you find under the Finishing, this one by default was set to auto, and you need to convert it to manual. And here you will get options, travels, iteration, physics. If you don't get the physical time, it means what's happened here. That's the things which I say. It means you haven't set or you haven't ticked the time dependence here. So if this one is unticked, then that option will not be able to achieve. So that one, that step, will not go through. So after set up everything here, you close that, and then you can go to Tools again, Flow Simulation, but now as a solve, you run as a batch run. And that's the batch run will tell you that's the software, but you need to select all closed monitors, and you will go through 1, 2, 3, Reynolds 1, Reynolds 1000, Reynolds to 1 to the power of 5. And then we'll go through it. My experience for this, which I will show you now when I run it, it's how can I get the results, because the results will take, I did it, it takes maybe about really maybe 50 minutes and doesn't finish. But for 2 cases, you get them very quickly. But I'll show you how can we get the results when the solution is taking too long and it's not going anywhere. So this will take a bit of time. I will pause the video and come back when it's finished. So if you capture the time, it's 8:55 when I started this simulation. It's performing the iteration for the case. So if now you can see, not in the tutorial, which one is performing for me. Mesh generation and the events, and trying to take the scenarios, how it's working, and you can see the calculations. It's on the way to performing. We minimize that. It's showing me here that this is the panel that's working for my simulation. Go back to it. You can see the calculation is almost finishing for one of the cases, and then we get the message very soon when it's done. If you have any always doubts, you can see here the number of cores and some of the information, the troubles, how long it will take, and the iteration mismatches. So now the Reynolds for 1E5, its calculation okay is done. Now it's taking the other case, which is the Reynolds for the other case, which I think is the Reynolds 1. You can check it. Value calculations, and tells you how many iterations and this stop and all this information right at one. So here is showing me that the convergence of the calculation is going in the right time, and see the calculation is going there. Iterations looks like it's finishing very soon, which good indication for us. Finished. So Reynolds 1 is also finished. Now it's going to solve the Reynolds 1000. That's the one many of you start commenting that this solution is taking a long time, but I will show you how can I stop the simulation and obtain the results and to do it. This is very interesting because one of the things when you see the simulation, it's not making much difference for my scenario, and every time it's still ongoing, but creating different results. I looked at this, it's not really, it's settling down, the curve is still going down for the drag coefficient, And to avoid this simulation will take a long time, you can see here it's already down 44%, and it's not overtaking that because it looks like it'll take longer time. And again, you see the estimated time, which it suggests last iteration finished, and by the time which we're getting at 8:58, and here's telling you all the information. Calculation time left is 27 or 37 minutes. I'm happy with 48% of the calculation because it's not changing any changes. So what we do here, you come to this corner, stop, and it will ask you, the calculation will be stopped. Do you want to save the results? I'll say yes. And then when you get the result, you can see all calculation he has done. And therefore, I will follow the tutorials again. I'll bring the tutorials again here, and I will follow that getting results. So I'm happy with that, folks. I will close it and then come back to the tutorials here. So what I will go, I'll start with, as stated here, in the flow simulation analysis tree, go to the results. So all goals, you could achieve them. So you could come in this way, but what you need to do is to load the results. See, it's not loaded. So I will select first the Reynolds one. See how very nicely click on it, and then right click and load. We'll start loading the results, and then under goals, I'll do this step again. You select, I add an extra goal, and then you show or export to Excel. It's up to you. And then you show the value. And this is what I'm getting for the first case. So here the values are 1.37, here is 1.36 and 11.099, and here is drag coefficient 11.07. Very close to it. There is something maybe in the software or some calculations you get there or there. And that's for the first case. I close that one, and now I double click on the Reynolds 1000, and you see I need again to right click, spin that, and then right click, load the results, and now the results will come for it. And then goals, insert, I will select all my options, and then show. I don't need to export them here for you, but you can export them. You see for the 1000, you get the value is really tiny, 144 and 1.4 the drag coefficients for that. So there's something slightly different from what we got there. Maybe that's the value 1.35, and there is some difference between them. Now, if I close that one and then go back and minimize that one, and then go, no, I chose the wrong one, and bring the Reynolds 1E5, and just make it that way, and then load the results. Now the results will come for that Reynolds. Now you say, I will answer you very soon about why we got slightly different numbers. Insert here for the 1E5. So when I insert the goals, I will choose them and then show. In my case, you can see the value is 0.815. We got 0.712, and the drag coefficient 0.69, 0.79. All of this, it's possibly because I stopped the iteration earlier, but you see the match of the issues is not exactly, they have the same error. So that's something you could investigate when we have different iterations or the software is trying to solve it for different values. So that's exactly how you can get the result for this example. And of course, now you can use cut flows and show many information you want to show, for example, velocity, and then you can show the results as you wanted to see them on this question. So I hope now this is easy for you. Just watch it and try to upload your tries, or also make comments or anything, and so we can benefit from it. Thank you.